Every few months, sometimes every few weeks, a familiar story starts circulating online. A Windows update rolls out, millions of PCs download it automatically. And suddenly social media, forums, and tech news sites are filled with the same complaints. Computers stuck in endless reboot loops, systems refusing to boot at all, blue screens appearing out of nowhere, printers vanishing, Wi-Fi breaking, audio drivers disappearing, performance tanking, or entire machines becoming unusable overnight. For many Windows users, this has become an expected part of owning a PC. You wake up, turn on your computer, see the message working on updates. Don't turn off your PC, and feel that quiet sense of dread because you have no idea whether your system will come back the same way it went in. This is not an exaggeration, and it's not a rare edge case. It's a recurring pattern that has defined the Windows experience for years. And the most interesting part is that Linux users, across distributions like Ubuntu, Linux Mint, Fedora, Arch Linux, Debian, openSUSE pop, _OS and Manjaro simply don't live with this anxiety. Updates on Linux rarely break systems in catastrophic ways, and when something does go wrong, users almost always have the tools and the control to fix it quickly. So why is this happening, and why is the experience so different? To understand the problem, you have to understand how Windows updates work in practice, not in theory. On paper, Windows Update is supposed to keep your system secure, stable, and up to date. In reality, it's a massive centralized update mechanism controlled entirely by Microsoft. Updates are pushed automatically, often bundled together, and installed with minimal user choice. Security patches, feature updates, driver updates, firmware updates, and even UI changes can all arrive at once. On Windows 10 and Windows 11, Microsoft has made it increasingly difficult to fully control when and how updates are installed. You can delay them, pause them for a while, or tweak a few settings, but eventually the system will decide that now is the time. Reboot your PC and apply changes whether you're ready or not. The problem is that Windows runs on an almost infinite variety of hardware combinations. Different CPUs, GPUs, motherboards, storage controllers, Wi-Fi chips, Bluetooth modules, printers, webcams, and obscure peripherals all need to work together. When Microsoft pushes a single update to hundreds of millions of machines, it's inevitable that something will go wrong for some users. But the scale and frequency of Windows Update failures suggest deeper structural issues. Drivers provided by hardware vendors are often outdated, poorly tested, or incompatible with newer updates. Microsoft sometimes replaces working drivers with newer ones that break functionality. Feature updates can change system behavior in unexpected ways. Registry settings get altered, services get disabled, legacy software stops working. And when something breaks, the average Windows user is left staring at an error message that offers no real solution beyond restart your PC or reset Windows. What makes this worse is that Windows updates are largely opaque. You don't really know what's being changed under the hood. You can't easily review a detailed list of changes before installing an update. Rolling back an update is often unreliable or time-limited. And if your system becomes unbootable, recovery options are limited unless you already know your way around Windows recovery environments, command prompts, and reinstall media. For many people, the only practical solution is a full Windows reinstall, which means backing up files, reinstalling applications, reconfiguring settings, and losing hours or days of productivity. Now contrast this with how Linux updates work across distributions like Ubuntu, Linux Mint, Fedora, Debian, Arch Linux, openSUSE pop, _OS, and Manjaro. The first and most important difference is control. On Linux, updates do not force themselves on you. You choose when to update. You choose what to update. You can update everything, or you can update only security patches, or you can update a single package while leaving the rest untouched. On Ubuntu and Linux Mint, the Update Manager clearly shows you what will be upgraded, what version changes are happening, and whether a reboot is required. On Fedora, updates are frequent but transparent, and the system is designed with strong separation between core components and user applications. On Arch Linux and Manjaro, updates are rolling, but users are expected to read update notes and news, and the system gives you the tools to manage changes responsibly. On Debian, updates prioritize stability above all else, meaning breaking changes are extremely rare. Another crucial difference is how software is structured and delivered. Windows updates often involve monolithic changes to the operating system, mixing core components with user-facing features and drivers. Linux, on the other hand, is modular by design. The kernel, system libraries, desktop environment, drivers and applications are all separate components. Updating your web browser doesn't require touching your graphics driver. Updating your graphics driver doesn't require changing your desktop environment. Updating your desktop environment doesn't require rewriting core system libraries. This modularity dramatically reduces the blast radius of any single update. On Linux distributions like Ubuntu, Linux Mint, Fedora, and pop_OS, drivers are usually part of the kernel or well-maintained repositories. The Linux kernel includes drivers for an enormous range of hardware, and these drivers are tested together as part of kernel releases. When you update the kernel on Ubuntu or Fedora, you're getting a version that has been tested across countless systems in the community. And if a new kernel causes issues, older kernels are usually kept automatically, allowing you to boot into a previous working version with a couple of keystrokes. This alone eliminates one of the most terrifying Windows update scenarios, where a system suddenly refuses to boot and offers no easy rollback. Linux package managers are another major reason updates are safer. Tools like apt on Ubuntu, Linux Mint, and Debian, DNF on Fedora, Pacman on Arch Linux and Manjaro, and Zypper on openSUSE handle dependencies in a predictable, transparent way. When you install or update software, the package manager knows exactly what files belong to which package. If something breaks, you can remove or reinstall a specific package without affecting the rest of the system. You're not guessing which mysterious DLL or registry entry caused the problem. You have a clear map of what's installed and where it came from. There's also a philosophical difference in how Linux distributions approach updates. Windows updates are often designed to push users forward, whether they want it or not. New features appear uninvited. Interfaces change. Default apps get replaced. Settings get reset. On Linux distributions like Debian and Linux Mint, stability and user choice are core values. Updates aim to fix bugs and security issues, not reinvent the system every few months. Fedora and Arch Linux are more cutting edge, but even there, the culture emphasizes documentation, communication, and user responsibility. When a breaking change is coming, it's announced. Users are told what to expect and how to adapt. Another factor is the open-source nature of Linux. When a Windows update breaks something, users have no visibility into the code. They can only wait for Microsoft to acknowledge the issue and release a fix, which may take days or weeks. On Linux, if an update causes a problem, the community can see exactly what changed. Developers, maintainers, and users can collaborate to identify the issue, propose fixes, and distribute patches quickly. This doesn't mean Linux is perfect or immune to bugs, but it does mean problems are surfaced and addressed in the open, rather than hidden behind corporate walls. It's also important to talk about reboots. Windows updates are infamous for forcing reboots at inconvenient times. Even when you try to schedule them, the system has a habit of ignoring your plans. Linux updates rarely require reboots, and when they do, it's usually for kernel updates. Even then, you decide when to reboot. On servers running Linux distributions like Ubuntu Server, Debian, and Red Hat Enterprise Linux, systems can run for months or years without downtime, receiving security updates without interruption. This level of stability and control simply doesn't exist in the Windows world for most users. Critics sometimes argue that Linux users are just more technical and therefore better equipped to handle problems. While there's some truth to the idea that Linux attracts power users, it doesn't explain the full picture. Modern Linux distributions like Ubuntu, Linux Mint, and pop_OS are designed for everyday users. They offer graphical update managers, clear notifications, and sensible defaults. You don't need to be a command line wizard to keep your system updated safely. In fact, many Linux users go years without a single update-related disaster, while Windows users with no interest in tinkering are routinely forced into troubleshooting sessions they never asked for. Another often overlooked point is testing. Linux distributions have staged repositories and testing branches. Updates are typically tested by a subset of users before reaching the general population. Ubuntu has development, testing, and stable channels. Fedora has Rawhide, beta, and stable releases. Manjaro delays Arch Linux updates to test them further before pushing them to users. This layered approach helps catch issues early. Windows Insider programs exist, but the line between testing and production has blurred, and problematic updates still reach stable users far too often. Then there's the issue of forced driver updates on Windows. A Windows update might decide that your working GPU driver should be replaced with a newer one, even if that driver introduces bugs or performance regressions. On Linux distributions like Ubuntu, Fedora, and Pop_OS, you usually choose when to update proprietary drivers like NVIDIA's. If a new driver causes issues, you can roll back easily. Open source drivers, which are common on Linux, are developed alongside the kernel, reducing compatibility problems. None of this means Linux updates are flawless. Bugs happen. Occasionally, an update will introduce a regression. But the difference is in frequency, severity, and recoverability. A bad update on Linux is usually an inconvenience. A bad update on Windows can be catastrophic. Linux users don't live in fear of updates because updates are not something done to them. They're something they participate in. They have visibility, choice, and escape routes. The irony is that Windows updates are meant to simplify things for users, but the lack of control and transparency often makes things worse. Linux's approach may seem more complex at first, but it results in a calmer, more predictable experience over time. When you run Ubuntu, Linux Mint, Fedora, Arch Linux, Debian, openSUSE Pop_OS, or Manjaro, updates become routine maintenance, not a roll of the dice. So when you see headlines about Windows updates breaking PCs, remember that this isn't just bad luck. It's the outcome of a system designed around central control, forced changes, and opaque processes. Linux users don't have this problem not because Linux is magically perfect, but because it's built differently. It respects modularity, it values transparency, it gives users control. And in the long run, that makes all the difference between dreading updates and barely thinking about them at all.